Welcome back, 126 fans. This is part 2. Please watch the previous video because this one I'm going to hop right into it. We're going to do 3 double integrals and we're going to reverse the order. So step 1 is to draw those inner bounds. So let's get right into it. So we are going to draw, the two things we need to draw are y equals 2 and y equals the square root of x. Y equals 2 should be on top. Done. Y equals the square root of x should be on the bottom. Done. And let's go look at those tick marks. The tick marks are 0 to 4. Okay, now I'm ready to shade. And now I'm ready to reverse. Now I'm going to do it in terms of y. The biggest and smallest y can be is 0 to 2. Based off of y, x could go from 0, x equals 0 on this side, to whatever this is, which is, if I rearrange it, it's x equals y squared. So 0 to y squared, x over y to the 5th plus 1, dx dy. Lovely. Let's do another one. So what do we have here? The two things I need to graph. Let's draw our axes. The things I need to graph are this, y equals 8x, which is a line. So we're going to draw that. Y equals 8x. The other thing we need to graph is the cubic, y equals 2x to the third. And I am going to check here. If I plug in 2, they both give me 16. So, but I'm going to draw this cubic. So if you don't know how to draw a cubic, cubics generally, and watch my video on graphing if you don't know this, but you need to just know the general shape. So cubic is going to come up like this. It's going to hit there. And I think it hits right at 2. Okay, this is 2. And we can already see the region. Done. If you're unsure, you could plug in some points. I mean, the points that make sense to plug in are 0 and 2, meaning plug in 0 to both of them, plug in 2 to both of them to plot those points. When I plug in 2, I get 16. When I plug in 0, I get 0. All right, now I'm ready to reverse the order. Let's do it in terms of y. So I'm going to label this y. Y can be anything from 0 to 16. And now the rest of the problem involves me figuring out what is on the left and on the right. On the left was that line. The line was y equals 8x, but I want it to be in terms of y, so it's going to be y over 8. Okay, that one's done. On the right is that cubic, y equals 2x to the third, and so I can divide by 2, take the cube root, and I'll be done. So y over 2 to the 1/3. And we're done. So it's going to be whatever, g of xy dx dy. So you can see it's all about graphing the region. And you can see as you step back, the main thing to do is to graph that inner bound. The outer bounds tell you the tick marks. The inner bounds actually tell you the functions. All right, let's do another one. So this one is saying we need to graph x equals y to the 1/3 and x equals y over 4. Those should be the right and the left. But let's see, this is the same as y equals x to the third. This is the same as y equals 4x. I do that just to sort of put it in the form we're used to. We're used to seeing things in terms of x. All right, now let's graph. I need to graph y equals 4x. Done. I need to graph y equals x cubed. Okay, now I get to do another cubic right away. There we go. Let's see, do they actually hit when y is 8? Do they hit? And how do I know that's y? It's here. I think they do. They both are 2. Okay, so we're set to go. And now instead of in terms of y, we want to do it in terms of x. So here's x. So we're going to say the integral from 0 to 2. The integral from the bottom one was the cubic, so that's going to be x cubed, to the top, which is 4x. And then the inside stays the same. Now this particular problem on the exam, it said to reverse and then compute it either way. So technically the original problem didn't need reversing. We could have integrated it as is, but the direction said to do it. So there's 3 more. Hope that helps. Draw the region. That's the key step.